Okay, hi students. I'm going to show you about the Making Electromagnets lab just in case you were absent, okay? So in the Making Electromagnets lab, we're on page 19, okay? And what we did was we made an electromagnet. So what you do is you take a wire and you wrap it around a nail. And this nail is iron, so it works really well at conducting electricity and creating an electromagnet. And then we just sanded the ends and connected to the battery, and voila, it's an electromagnet. It actually will pick up, show you, pick up metal. So we wanted to set this up like an experiment, not just making an electromagnet. So we set it up with our hypothesis and control and everything. So the hypothesis we decided to come up with is if I make an electromagnet with 100 coils, then it will pick up more mass than 50 coils or 10 coils. Okay, so we wrote that as a hypothesis, and I'll post a picture of some of that I wrote down. And the control group in that situation would be 50. 50 would be our control number of coils. And then our experimental group would be 100 or 10. And so those are gonna be the ones we're experimenting on. Constants between the groups. I'm using the same batteries, same nail, same wire, same scale to weigh it. This will be my scale right here. So same things. The independent variable is the number of coils. The number of coils around the nail. The dependent variable is gonna be the amount of mass it can pick up. Okay, so we got all that set up, and then go ahead and write down the step-by-step instructions. Now I'm gonna get to the experiment, okay? Gonna get to the results. So I'm gonna set this up, see if I can get a good view here of my electromagnet. And here's the mass right here. See if I can get you see most of it. Sorry about that. It's kind of a hazard of me doing this when I'm the only person here. Okay, so I'm gonna take my electromagnet. This is hot, so we wore gloves in class, but Miss Hanson's an old lady, so she can touch it because I have no nerves in my hands left. Okay, so, we're gonna pick up as much as we can, and we're gonna put it on the scale. Whoops, it turned off. I don't want it to zero out there. Let me try that again. My scale turned off, I had it on. Okay. That on the scale, and that's 2 grams, 2 grams. So right here, I'm gonna write on my table, 2 grams under the 50. This is 50, so 2 grams. Let's try it again. Let me take this off. It's having a hard time staying there, isn't it? Okay, whoops, add those. And that's 4 grams. So write 4 grams on the 50. Okay, I got those. Whoops, my goodness, I keep dropping stuff. Okay, and I got another 2 grams. So write 2. Okay, write 2 there. And then you're gonna average those up. You're gonna average those up. So 2 plus 4 plus 2 equals 8, divided by 3. Okay, you're going to average those up and get that in your number, okay? All right, so that was the 50. Now, we are going to do the 10. Let's do the 10. So you can see here, there's only 10 coils. It's not very many. Not very many coils on there. Okay, so this is gonna be probably a weak electromagnet. Just pick up this little guy right here. Okay, 1 gram, write that down under 10. It only picked up 1 gram. Okay, let's try it again. One gram again. And the last one is 1 gram. Can only pick up 1 gram with 10 coils. So obviously if you add those up and divide by 3, you're gonna get 1 gram. So that's your average on that one. Okay. So that's that. Now I've got 100 coils. Now in class, we just added to the same nail, but for speed, so that this video wouldn't be like 30 minutes long while you watched me coil, I did this in advance and I got them all coiled on different nails just to help it go faster for my video. So now I have 100 coils. Okay, you can see 100 coils on there. I kind of taped it on to make sure it didn't slide off. Now let's see if I get more mass. Oh yeah, looks like I got more mass here. Okay, 10 grams. Write that down, 10 grams. Second trial, 6 grams. Third trial, 9 grams. 9 grams. All right, so you're gonna add those up and divide by 3, and that will tell you the average for a 10 coil, okay? So then we're gonna make our analyze results. So that's just telling me what the numbers mean in the words. So you'll just say my average for 10 coils was this, my average for 50 coils was this, my average for 100 coils was this. Then the conclusion, the last part is the conclusion. So in the conclusion, we're now making a claim about all electromagnets, right? If you were going electromagnet shopping, what would you look for a strong electromagnet, okay? And so our claim is going to be that the more electricity that you have going through the electromagnet, so the more coils, then the stronger the electromagnet or the electromagnetic force. Then you're going to support it with your data. So you're going to write in there about how you got more with 100 coils than you did with 10 and 50. And then you're going to provide the reason. Okay? The reason why is because the more electrical current that you get going through the nail, then the greater the electrical or the magnetic force, because every amount of electrical current creates a magnetic force. So I actually wrote all this down on the board, and except the support with data. Obviously, I didn't have everybody's data, so I can write that. But I wrote the claim and the reason on the board, and I'm going to post a picture of that attached to this video so that you can look at that. And if you can't make it in your own words, then you can copy what I wrote on the board, okay? Then at the bottom, you're going to write that electrical current creates a magnetic field, and moving magnets create an electrical current. And then it says, name 5 things you've used today that use this relationship. Now, that's anything, right? That's anything that's electrical. You probably use that if you use your refrigerator or your microwave or your car or a light switch or any of those things. You have used electromagnetic force today. So write 5 things down that you have used today. And hopefully that helps you and gets you ready for the test. Okay, we'll talk to you soon, guys. Thanks.